It's time for the CyberSecurity News Byte with Jim Guckin.
CyberSecurity News Byte, episode number 67 for August 7th, 2023. Burger King's password mistake, growing danger of LOLBAS, proper decommissioning of devices, and Microsoft fixes a flaw after being called irresponsible by Tenable CEO. Everyone, welcome back to the show. I am your insufferable host, Jim Guckin, here with another week of cybersecurity news stories that I think you need to know, or at least pay somewhat attention to, because they could impact you. And we have, and not that I don't love my stories every week, these are a grouping of stories that I think are very telling in the world of cybersecurity for this thing. They're not necessarily the specific stories themselves, but they are the messages we can kind of get out of those stories. For our first story, I want to talk about Burger King's password mistake. So I'm sure you're aware of who Burger King is. They are a 19,000 restaurant, $1.8 billion organization. And they have a French website. Of course, they're in France like everything else. Well, on their French website, on the subdomain that hosts their job postings, and it's fixed now, they kind of leaked their own password to a database. And this was found by the Cyber News research team back in June. They found a publicly accessible environmental file. Now, if you're not a web developer, you may not know what this is. They're .env files. And their whole point is to store environmental data so that you don't need to encode it into your web apps or websites. So think of this as like your database files, any kind of secrets that you may want. You don't have to give this to the developers because they can just do an include with it. So they're typically, as I said, used to store sensitive data like passwords, API credentials, and anything else that you may not want to be written directly into the code. Well, as it's part of the story now, this is what the problem was Burger King kind of misconfigured this code and was available for people. Now, I should say that the fact that the code itself was leaked is in itself not a leak. It is part of what someone could do to exploit it. Because all they could see is the username, password. The database was the local host to the device, meaning you would have to find some way of exploiting something else to take advantage of it. But it's still not good process to kind of, make that known. So the file showed credentials to the production database for their job searching piece of this. Now, the researchers themselves couldn't necessarily go in and figure out what was in the database, because then that's called hacking. But we can make some assumptions here, assuming that, the job posting information is there, what jobs Burger King France had, as well as maybe the job hunter's information, if name, phone number, previous job experience, that could all be there. But like I said, even knowing the database information doesn't necessarily mean you can get to it. It was just their credentials. You still need a way to get in, query and or exfil that database for it to become really a problem. Now, you would have to kind of, pivot to find some other, PHP or whatever the code was written in, web flaw to be able to get that. If you could modify code on the website, then you could grab all the data and query that database all you wanted. That's part of the design function. But once again, this was only just the environmental variables, which Burger King France immediately fixed once it was brought to their attention. Now, I did see a lot of talk about in the environmental variables, they had a Google Tag Manager, which is used to optimize, update measurement codes and code fragments from Google so that you kind of know what's going on. And this was part of it. So maybe, people were concerned about being able to get information from it. The best I could find doing my research on Google Tag Manager is the best they could do is change it themselves and kind of see what people were going to the website for. I mean, and you correct me if I'm wrong. You can always go to the show notes or email me at jimguckin.com. I'm willing to admit when I'm wrong. Coding is not necessarily my specialty. I tried it when I was much younger, and I learned very quickly that I suck at coding, mostly because I can't spell. It just, you don't want to be a coder when you can't spell, right? And I will misspell the same thing 8 different ways. Doesn't make good when you're starting to reference stuff, but I did try it. But I'm not up to date on, even though I do kind of code some things on my own websites. I mostly use other tools to do it, so I'm not great at it. So the best I could figure out was that you can change it, and then I could see who's going to the job site and get some information there. Nothing that I think would be very dangerous to the people at the job site. But what can you learn about Burger King and their misconfigured environmental file? 1, ensure the proper permissions for any kind of environmental file, that only the people who need to access it can. Make sure it's able to be called by your web apps and other things, but doesn't necessarily mean it has to be visible to everyone. In this case, it was visible to everyone on the internet without much need for any kind of coding language. And that's where the problem was. Even if this would have been visible to everyone in the environment itself, not the best security method. You really want to limit it down, zero trust, to who absolutely needs it. But at least it's minimized there. This was something that anyone on the web could see with the right knowledge. And that's where it comes down to. It's always the right level of knowledge that you need to make this work. And in this case, the researchers had it. They just couldn't go much further than that. And they could have tried. I mean, but they don't want to be hackers. They just want to be like, hey, we found this. This is bad. We want to let you know. But if they were, they might have been able to pivot this to some other attack and then gotten that information down. Once again, not like it's Burger King proprietary secrets, but it's still something that you necessarily don't want unauthorized parties to get. Now, another way of doing this is once you ensure that the proper permissions is depending on your hosting provider. If you do Google or AWS, some other things. And I just learned about this, so please, if I get any of this wrong, absolutely tell me how horrible I am being with it. But there is such a thing as a dedicated secrets manager. In fact, I read Google has one, and there's other ones you can use. The only downside to this is you need to learn a different piece of technology. It's not as easy as using the environmental file that's there. It's in your environment. It's not hard to look at, to read. It's very simple coding, but this way it's a separate piece so that even if your environment itself is compromised, there's still another segment of control over it. That's probably considered the best way of doing it for a security standpoint, though I would say the easiest way, if you don't have this, you don't have the money for this, is just to ensure that you are utilizing the proper permissions in your environmental file to keep your stuff safe. Because while in Burger King's case, this was caught by security researchers, and they did everything they could to go, hey, look, be aware of this. We didn't try to take advantage of it, but we could have. That's what you need to watch out for, because hackers are not going to tell you first. They're going to try to take advantage of it. And who knows what evil ways they can do things. For our second story, and this is something that I think everyone needs to pay attention to, but it's an evolving thing. There's a thing called LOLBAS, or it's currently called LOLBAS. It used to be called LOLBINs. And LOLBAS stands for Living Off the Land Binaries and Scripts, and now some libraries. So I don't know if they're going to change the name again to LOLBAS. But LOLBAS seems to be where it's at. In fact, there's a project LOLBAS that you can find in the show notes for the show. And what formerly called LOLBINs, which is Living Off the Land Binaries. That's what it used to be called, and they found some scripts, and now they found some libraries that all can do this. And the scary thing about this, if you're not aware, these are local executables, binaries, scripts, libraries that are native to your operating system that can be exploited by malicious actors to do things. Mostly exfil data or run commands they shouldn't run. And if you think about this from a cybersecurity kind of thought, they don't need to install things. So, a hacker breaks into your environment, they download, let's just say Cobalt Strike. There's a chance they'll get caught because that's not something that's not normally in your environment. Your endpoint detection and response may catch it, stuff like that. This stuff that I'm talking about right here is part of your computer. It's doing what the computer says it should. It will not be detected by any of your software. So it is very dangerous. And in fact, the LOLBAS project has a whole list of these. Right now, it was about 150. And that have been or could be utilized by malicious actors to get their stuff out. So the LOLBAS project is something that I'd seen pop up in the news last week. And I was fascinated by it because, as I said, I can protect my environment from things that may not be there. I can whitelist applications, stuff like this. But these are applications that belong to it. And the reason I'm more cautious of it, and the reason it came up in the news, was because there was a security group called Pentera, Pentera, and they had a security researcher who I'm going to apologize because I'm pretty sure I'm going to butcher the name. Nir Shako, Nir, and then last name is Chako. And the security researcher and Pentera was like, hey, let's see what we can find when it comes to LOLBAS. And they found at least 3 downloaders in Microsoft Office. That thing that you have installed everywhere in your environment. They found them. They found they were able to use things as downloaders, MSO-HTMED.exe, MSPub.exe, and ProtocolHandler.exe. Now, once again, these are just 3 that are built into Microsoft that you have installed. And there's more. They're constantly finding these applications that you need to pay attention to because they're being instructed to do things outside of what they were intended to do. And they are going to become, and we've talked a little bit here and there about LOLBins, I think, in a couple of hacking stories a couple months ago. These are going to become a great tool for hackers as people start to learn to exploit these things. Because you don't need any external stuff. Now, I will say your majority low-level hacker out there who is going to use an access broker or a malware as a service or even ransomware as a service, this is not going to apply to them because they're going to come in through something that's already there. But the initial access broker, the initial entry into your environment, they may be the ones who are going to use off these this LOLBAS or LOLBins. And they're very dangerous because they're there. In fact, I got to witness someone using them, and security tools didn't trigger on it because it was doing what it was supposed to do. Now, there were some things in the way there, but it goes to show you how versatile these things can be and how they are being picked up by some of these bigger malicious groups who have a little bit of skill come in. Because if I don't have to download something to exfil data from a network, if I can just use this MSPub file to send data up, well, I'm not going to worry about other tools. I'll try this first. Now, if this doesn't work, if I can't get the living off the land binaries and scripts to work, then yeah, maybe I'll download a tool that's separate from this. But it really becomes, the danger is coming from within your own network. The call is coming from inside the house, from the old horror movie trope. You don't need to download something else. You don't need to do other things. All this exists in your network. Everything a hacker needs is in there. And you can go, and I recommend highly that if you're listening to this in front of a computer, go to the LOLBAS project notes or show notes, have the link there. But if you're in your car, I highly recommend you take time to go through this and look at the 150 plus, because God knows how many they're going to get to by the time we're done. Binaries, libraries, and scripts that exist in your network that are part of applications that you may have and understand them. And if they're not needed, get rid of them. But put monitoring in place to see, is there a large abnormal removal of data from your environment? Doesn't matter if the application is or is not legitimate. Because as I said, there are 3 here that we mentioned that are all in Microsoft Office. So it's not, is it legitimate? Do you all of a sudden see a spike in user A or device B moving stuff, across HTTP or HTTPS from your environment? That's what you need to look out for. And that's the hard thing to do, is because someone may trigger alerts like this every so often. But you have to make sure you have the tools to detect it, because as I said, this is not malicious software. This is built in. And it's only going to get more and more popular. In fact, as much as I love the LOLBAS project, there will be malicious actors who take a look at this and go, oh, all right, I just have to figure out how these work. I have to figure out the scripting to get this mspub.exe to send files on my behalf, or send data on my behalf. And that's the dangerous part. So highly recommend you look at this. And if not, if you're security and you don't know what LOLBINs are, or LOLBAS, or LOLBASOL, whatever they're going to call the new end libraries, take a look into it, because this is going to be the next level of danger for us. Because you don't need anything external. You don't need Cobalt Strike. You don't need any of these malware packages. It's there. You have it on the computer. They don't have to bring their own tools. The tools are there. They're living off what your computer has, which is why it's called living off the land. Because just like, settlers, when they moved across, they could just live off the land, and that's how they did. Same with computer hackers. They don't need to bring anything with them. They have everything they need to exploit your system on your system. So please check that out, because they will. And this is going to be a lot harder attack to watch out for, because an XDR or endpoint detection and response, malware, scanner, antivirus, whatever you want to have, they're not going to detect legitimate software being used semi-legitimately, or maybe not semi-legitimately, even not intentional, but it's not malicious. It's not. It's weird, but it's not malicious. So how do you expect them to detect this stuff? So recommend go to the LOLBAS site, the LOLBAS project, and look at all 150 plus versions of this, because this is dangerous. And this is what caught me in the news, was the fact that this security researcher found it in Office. And I had seen the LOLBINs before. I had seen how they were exploited, but I didn't know there was 150 of them, and I didn't know that Office, the thing that is installed across every corporation out there, is a piece of it. So definitely something to worry about there. For our next story, and this has been one of those things that has worried me for a while, and it's about properly decommissioning devices. And there was a story, I want to say 10, 15 years ago, maybe, that a news organization had went down to, I believe it was South America, and they had purchased secondhand copiers. And this was before they were by default encrypted or even had an encryption setting on them. They went down and they were able to grab these devices, take the hard drives out of them, which was an old red team tactic to begin with anyway, which was to take them out of there, because most of the time there's some storage device in your big copier in your office to store files, whether it's going to send it to you or hold a copy for you and then you pull it down, or FTP, or move it. However it is, most of them had this functionality built into it. And when they purchased these, there was no encryption at the time, but they were able to get the devices and get the data off. And there was like social security numbers and medical records and all this, because no one was aware that this was a problem. And I've always had this concern that, most organizations I go into is to make sure that everything is done to make sure that, our copiers are safe. Fast forward now, in the age of IoT devices, where things are on the internet now. This news story comes up from Rapid7. And they analyzed 13 different infusion pumps, specifically 3 different models. The Alaris PC 8015, the Baxter Sigma Spectrum Model 35700BAX2 and its associated wireless battery module, and the Hospera Abbott Plum A Plus with MedNet. And in their thing, they kind of said, look, these devices have data on them that is somewhat concerning, at least from a network, standard. Now, I should say, Rapid7 has said, and the manufacturer said, these devices are no longer manufactured. But if you've ever worked in business anywhere, especially in the medical field, because it's not manufactured does not mean it's still not utilized in numerous medical organizations around the world. Not everyone's on the cutting edge. Not everyone's even within end of life for some stuff. In fact, very rarely have I found an organization that does not have an end of life piece of equipment that they require to run because they don't have funding to change it over. But in this Rapid7 report, which was really interesting, they attempted to extract some sensitive data off the devices. Some of this was on the device's flash card. Some of it was observing the communications on the serial bus. Some of it was even removing the flash memory chips from the main circuit board and seeing what happened. Now, this is all a level of hacking that is beyond me. I'm not a big hardware hacker, but I love when people figure out ways of doing this. So here's what they found out. The Alaris 8015, they found from the device host names with domain information. Not really the best, but all right. They connect through it or they see it on the network. Maybe that's fine. The AES keys for the encryption, not the best. The SSID of networks near it, not the greatest. Clear text Wi-Fi pre-shared keys, PSKs. The password that you use to join in there, or the passphrase, not good. Also, the credentials for Microsoft Active Directory authentication. Why? Why is this on this device? And then your generic Wi-Fi configuration settings. So they have everything they need from this device to connect to the network that it was a part of prior to them purchasing it secondhand. And they looked on the Alaris 8015 website. There's no documentation regarding the purge of data from the Alaris. There's no decommissioning rules found online. Though Alaris did publish some security bulletins that are available for organizations having support contracts with Becton Dixon, the Becton Dixon Company. BD. Well, that's great unless you are not using them, then I guess you don't need to wipe your data off for any security reasons whatsoever. This is why it's dangerous. Look at all this information that's available on a device that someone probably is like, oh yeah, it doesn't have anything, let's get rid of it. And this is the danger with IoT devices because they can store some information. And you have to know what it's storing. Because you may just think it's Wi-Fi data. In this case, I would have never guessed that the Microsoft Active Directory authentication credentials were on this device. I mean, I've never used them, so I never configured them. But this is what you have to kind of be thinking. Now, the second device, the Baxter Sigma Spectrum 35700BAX2 device with its wireless battery module, had Wi-Fi configuration data, meaning it had the Wi-Fi protected access passphrase, the passphrase to get onto it, though it was, in this case, converted to a 64-bit character hex. So it's still usable to join that network. Now, I will say, not me. Rapid7 did say that they provided documentation detailing the steps that should be taken to reset wireless configurations and remove any other information from the devices and the wireless battery module before getting rid of it. And I think every IoT device maker should give you directions on how to wipe that device easily before you donate it or sell it or throw it in the trash. Because you don't know what kind of information you're giving other than that. Or, even if it comes down to create a fake Wi-Fi and join it to that before getting rid of it. Now, the final one, the Hospera, Abbott, Plum A+ with MedNet, well, they found just the Wi-Fi configuration data, and not necessarily as bad as the first one, or even the second one, but still information that you don't necessarily want to give out. Now, they found that there was no single procedure that the Rapid7 could find for removing all the critical data, such as PHI, personal health information, and Wi-Fi configuration before decommissioning. So, all right, I take that back. Maybe it's worse than the first one, because at least I'd rather have access to the domain than health information. And I should say, Rapid7 pretty much said, look, the tools to do this are easy to get, and they're only around $250 to $1,500, meaning this is open to a wide range of, or a low range of malicious actors out there. And I wanted to do this story because this is what I want to ask you, is how closely do you pay attention to the decommissioning of any IoT device? Because almost every organization has them nowadays, whether they are necessarily tied to a better network or a network with any kind of data on there. You need to pay attention to this. As much as we want to distance ourselves, we're like, well, that's not really truly a device. Hackers only need a door to get in. They will eventually find a way to pivot to some other device. So if they can only get into like a Bluetooth soap dispenser, but that sits on your network to let them know, hey, look, you need to refill this stuff. That's a pivot step that they can eventually figure out. I should say, I'm the mindset that anything can be hacked. Anything can be exploited. You just need the proper motivation. And the real key for good security is not letting that door be open in the first place. So don't give information you don't need to. So when you decommission IoT devices, you need to make sure that they have no information that is of value outside. Shouldn't point back to your company, shouldn't give you access to your network, shouldn't have any data on it whatsoever. But the problem is, and we've talked about this before in the show, is IoT device manufacturers do not care. Most of them just put the thing out and they will never put updates to it. It's just a piece of device they sell for one period of time. And that's the dangerous piece. And I think that we need to demand better from our IoT, device manufacturers. Especially if you're in a field or an industry, I should say, rather than a field, an industry that has sensitive data, whether it's customer data, whether it's health information, whether it's banking information, whether it's secrets from the government, whatever things that should not be available to everyone. Those are the places we need to make sure that IoT device manufacturers are held to task and give you how to wipe that device before getting rid of it. Without a support contract, like, it shouldn't be like, oh, well, if you work with our manufacturer here or this supplier here, then they'll help you wipe it. No, it should be made free for everybody. Because all it takes is some enterprising person like this Rapid7 security incident or security investigator. They found the data there, and it wasn't hard. Pretty cheap to do. So we need to, as a group, make sure that we hold them accountable and make sure that we keep our sensitive data safe. And finally, this is one that I just enjoy because I've had this problem where in some of the upgrading CVEs scoring models, they have the vendor themselves saying, hey, this is how sensitive we think we are. And there has been stories we covered on the show in which one vendor goes, yeah, well, this isn't really a big problem. In fact, I believe it was Microsoft Access. It was some Microsoft tool that not a lot of people were using. And Microsoft's like, well, it's not really a big deal. But if you're one of these customers, it is a big deal. This is a flaw that you have that they aren't fixing. And this is where today's story comes in. because Microsoft, in their Power Platform custom connector feature in Azure, just recently fixed a security flaw. And the security flaw let unauthenticated attackers access cross-tenant applications and Azure customer-sensitive data. And Microsoft really wasn't trying to fix this as quickly as they should. So how this started, the root cause for this, it stemmed from access control measures in Azure. And this was launched by the Power Platform feature, which uses a custom C# code to integrate into a Microsoft managed Azure function feature and HTTP trigger. I'm not going to pretend like I understand what any of that actually means. But there's a custom code that was not using proper access control measures, which let a malicious actor possibly take advantage of this. Now, the custom connectors usually happen via APIs. And the APIs are usually authenticated and encrypted. But the system itself wasn't actually checking for that authentication. It was like, hey, if you have authentication, great. If not, that's great too. And this led to Tenable being able to pretend to be attackers and exploit the unsecured functions of the host and intercept OAuth, client IDs, and secrets. OAuth is that thing that lets you say, hey, yes, I'm in the system. It's like a token. So if you have it, you can tell the system, yeah, we talked together, we're fine, we're great. So that would have been the end of it normally. Tenable said, hey, we found this. And Microsoft would be like, all right, we're going to fix it. But it came to a drag down, knockout kind of fight between Tenable and Microsoft. Because Tenable said, look, this is not an issue of disclosing the information. This was Microsoft not taking the proper actions, because Tenable was able to access and interact with an unsecured function from hosts. And from there, they could trigger behaviors that could have further impact. Once again, we talked about pivoting here. They could have possibly pivoted. And Tenable had pointed out, because the nature of this service itself, the impact would vary from each connector, depending on how much access they could get or where they could do the pivot. And that unless them or Microsoft wanted to really figure out how big of a problem it would be, it was hard to say, because they'd have to do exhaustive testing. Tenable very quickly discovered the authentication secrets of a customer who was a bank, with the bank's permission, obviously, to see how bad this problem was. So they went to one of their customers who was a bank and said, hey, we're aware of this flaw. Can we test it in your environment? And the bank was like, absolutely. And they proved it existed. And Tenable also shared a proof of concept exploit code and information on the steps required to find the connectors that were vulnerable and the host names, and how to create the post request, the send request, to interact with unsecure API endpoints. And, well, once again, if Microsoft did their job, that would be the absolute end of the conversation. But Microsoft decided not to do that. Microsoft initially said, look, the researcher who exploited this issue, he's the only one. We're not heavily concerned. Red flag. Red flag. If one person can do it, there's only a matter of time before someone else figures it out, especially when it gets released. Now, after further analysis, in July, Microsoft determined, well, there were some Azure functions that were in a soft delete state that had not been properly fixed. And finally resolved all customers on August 2nd. That was, of course, after they tried to fix it back on June 7th. So June, July, August. 3 months. June 7th is like, oh yeah, we fixed it. No, we're good. And then Tenable's like, no, it's still vulnerable. So Microsoft took 5 months to address an issue. 5 months to address a serious issue that could have led to severe compromises. Only after the CEO of Tenable went on a rampage against them. 5 months. And the CEO of Tenable was just he was vehement in his criticism against them. And their initial response, calling it grossly irresponsible, blatantly negligent in a LinkedIn post. The CEO of Tenable said, did Microsoft quickly fix the issue that could have effectively led to the breach of multiple customers, networks, and services? Of course not. They took more than 90 days to implement a partial fix, and only for new applications loaded in the service. And this is something I need to warn you about cloud providers. They fix things and then push it for new applications or new services or new hosts only, because they don't want to break anything that's currently there. So they will they will put this language out saying our best practice is to do this, but they don't turn it on by default. And people think the cloud by default is safer, and to a degree it is. But when it comes to the security settings on that, those AWS, Azure, GCC, Google, whatever cloud provider you're using, they push some of that back on you. They're not going to turn on all the necessarily security features. There's a default state, which is somewhat secure, and their documentation is going to say, look, you need to turn it on for you and to make sure it doesn't break things. So the whole adage of, I'm going to push up to the cloud because I'm pushing the risk to the cloud is a false statement nowadays. And Microsoft proved it. They were aware there was a problem. They only fixed it on new devices, meaning at that time, if you had any old devices, you were just left blowing in the wind until it became so bad that they had to fix it. And Tenable even said, that means as of today, the bank that I referenced above is still vulnerable more than 120 days since we reported the issue, as are all of the other organizations that have launched services prior to that fix. So you need to look this up if you have an Azure environment and you're using APIs. Because anything before June 7th, the fix wasn't there. Now, as I said, August 2nd, Microsoft has said, look, we fixed it for all customers, but I would still check because they are pushing this back on you. Cloud providers do not necessarily mean that you are safe. You still need to take that security in your hand. If you are a business that just has, stuff in the cloud, you don't really have a security team, this is why you need a security team. You are not pushing the risk to the cloud, because they've pushed it back to you. They have an agreement. Here's our terms of service. We recommend that you turn these features on. Whether you do or not, it's up to you. But then you're taking the risk back. They can say, look, we told you, look, you need to do this. You need to rotate this. You need to change your keys. You need to change your passwords. The fact that you didn't do that's on you, not us. Because we told you to do it. This is why you need properly informed teams. The cloud is safer than your own servers? Yes. Is it safe? Absolutely not. And that's something you need to think about when you move to the cloud. Everyone, thank you so much for listening to the show. Don't forget, we are a weekly podcast. You can go on our website, cybersecurity.newsbyte.com, to find all of our shows and find the show notes for this with all of the news articles and stories I've talked about, so you can get more information on them and follow up for them. For example, in this one, LOLBAS, look at that LOLBAS project, because that's really what you need to start learning about. All of that's available at cybersecurity.newsbyte.com. You can find all of our shows on the whatever podcast software of your choice. Please interact with it, like, comment, whether you love it or hate it. I'm always open for some feedback. So please, on the podcasting platform of your choice, interact with me. If you want to talk to me, you can always email me, Emmy@jimguckin.com, or you can go to my website, jimguckin.com, and learn more about me. But please, take some time, pay attention to security, and we'll talk again next week. Remember, stay safe online. Have a good one.
You've been listening to the Cybersecurity News Byte with Jim Guckin. Learn more about our show at cybersecurity.newsbyte.com.